Lesson 7.3, review packet 7a. Solve each equation for x. This is very easy. I don't think you need my help. If you need my help to solve this problem, that means you have a problem. Next page. Use ZPP, find all of the solutions to each equation. ZPP means that stands for zero product property. That means you have two chunks here, one parentheses, whatever the number, and this is whatever the number. If you multiply these two numbers, then you have two numbers, whatever, right? Multiply, that equals 0. That tells us that either this one, or both has to be 0. Whatever this number is, if this is 0, 0 times whatever number is 0. If this is whatever number, but this is 0, obviously, whatever number times 0 is 0. Or, if both numbers are 0, then it's equals 0. So what we have for part A here is x equals 8, x minus 8, and x minus 23. So this x minus 8 has to be equal to 0. So what minus 8 is 0? Obviously, it's 8. The same reason for this should be 23. So the solution of part A is 8 and 23. Use that idea and solve the rest. Number 10 is each statement true or false? Explain. If the product of two integers is divisible by 5, one of the integers is also divisible by 5. Is that true? So let's take a look. So you have two numbers. One integer is divisible. The product. So whatever number times whatever is whatever. That is divisible by 5. That means that's 5 times some number n. Okay? And it says if this is divisible by 5, then this or this has to be divisible by 5. Is that true? I think so. Yeah, because for example, so 5 times, so this number, let's say that's 25, that's easy. So 30, okay? Then it's got to be 6 times 5, or 5 times 6. Then one number is divisible by 5. Or it could be 3 times 10. The 10 is divisible by 5. How about 2 times 15? 15 is divisible by 5. So that must be true. Is that true for 6? We got to be really careful. If it works for 5, it doesn't guarantee that it works for 6. So I want you to think about that. Number 11. Consider these two identities. Are they different? Explain. So let's take a look. So we have x plus a, x plus b. So let's set up the table. Expansion box. And complete the table to see if it is true. It equals to the right side of the equation. Do the same thing for b. Number 11. Number 12. Use exercise 11. Factor x squared plus 5x plus 6. So right here we have 5x, and this is 6. So this says if this is true, then a plus b, that means whatever the number you have right here plus whatever number here has to be 5. And also right here it says a times b is right there. So whatever number times here and whatever numbers times here, whatever number here times whatever number here, a times b, has to be 6. Is there such numbers? Is there any two numbers that adds up to 5 but at the same time give you the product of 6? In other words, is there any two numbers that gives you 5 by addition but gives you 6 by multiplication? Those should be a and b, right? So a plus b is 5 and a times b is 6. Is there such number? What's a and b? 14, write about it. Which equation is more difficult to solve? Explain. You don't really have to solve it, but explain which one's more difficult. So here, it looks more complicated right there, but you got 0 right there. Right here, it looks simple, but you got 20 here. I want you to think about, here's a hint, ZPP. I want you to use ZPP when you write about it. I want you to use that concept in the word. Okay?